Yeah, it is recording now. Thank you.
Okay.
Excuse me, sir. I think we can start.
Okay, just give me a minute. We are going to get started.
Another thing, sir, I'm seeing here some members are not allowed to enter. You are the only person to give them permission.
Okay, I've seen them. I've admitted them.
Okay, thank you.
Okay, anyway, I believe we all have access to notes. So for the introduction, we're basically going to run through these notes, and then we shall be able to, then we shall proceed accordingly. In case there are people who come in and in the waiting room, you can just alert me and then I'll be able to admit them.
There is one in the waiting room, sir.
Okay. Okay. Good morning once again. Okay, so I'll just give us an introduction. So the name is Ndejje, and these are my contacts. So you can be able to reach me along those various lines. So we shall be discussing quantity surveying, and our main focus is going to be what we refer to as measurement of building works. Our main focus is going to be measurement of building. Okay, so what, as you can see, our introduction straight away runs to bill of quantities. Our main focus straight away runs to bill of quantities. And why is this so? We're trying to see the end product is how much would it cost, how much would it cost to carry out a certain, how much would it cost to carry out a certain project? This is the this is the end product of what we are looking at in quantity surveying. How much materials are we going to use? What are the various quantities of materials that we are going to use? So ideally, this is the basic principle of what we are trying to look for. So at the end of the day, we need to know two things: the quantity of materials that is required and the cost to put up the project. So those two entities are calculated separately. For the quantity of materials or works, let me say at large, not necessarily materials just, but the quantity of works to be carried out, ideally, we look at the measurement, what we call measurement of building works, because that's our focus. So for this semester, or for this course unit as per now, our focus is going to be measurement of building works. Then two, we have what we call estimation. Now that's the other side. After you have what After you have the amount of works to be done, then you need to cost these works. You need to cost these works, and then we produce a BOQ with quantities and with costings. Okay, so that's what we are looking at as per now. So to start it off, we're starting with a bill of quantities, and we're saying due to the complexity of building operations, it will be impossible for a contractor to price a large construction project without a bill of quantities. So for this reason, a bill of quantities is the major tender document for construction works. That is to say, because in tendering, we're basically looking for that person who is going to do the project and at what cost is it going to be agreed upon, among other contract documents. So here, it's very important for somebody who is taking on a very large project to have a bill of quantities, because it's harder to estimate, say, a 5-floor building as compared to maybe a 2-roomed house. So given that scenario, it shows you the need for a bill of quantities. Okay, so we come here, say according to the Uganda government procurement guidelines, a bill of quantities is one of the tender documents for works exceeding 25 million. As we shall see, as we carry on, okay, so therefore here we come down to the main purposes of the bill of quantities. 1, it enables all contractors tendering for a job to price on the same information. Now, as we know, what happens is we prepare a bill of quantities for contractors to price during tendering. What happens is the client, through the quantity survey of the client, they formulate a bill of quantities, just like we shall be doing, which has the different works that are to be done. So of these works, the different contractors price. For example, if it's laying a slab, we indicate the type of slab that we want done, the size of the slab and everything. And then the different contractors will be able to price on that information. So that's what we are saying. It enables contractors tendering for a job to price on the same information. Then 2, it gives an itemized list of the elements of the buildings with a full description and the quantity of each item, which assists the building owner and the successful contractor in assessing material and labor requirements. Still, here we see that it breaks down the various elements of the buildings that are required, full description, describing the type of windows to be used, the type of doors to be used, the steel, and so on and so forth. So in it all, it helps for planning purposes, in assessment of materials and labor requirements for the job. Then it is used in the valuation of work done at any time during the execution of the works and at completion. That is to say, if at any one point during the works, you need to know how much work has been done so far, all you need to do, for example, if construction began in the foundation, you can no longer see what is in the foundation, right? And at this point, it's maybe on the 1st floor level. All you need to do is to go to your BOQ. And because the BOQ, like we've said, it is an itemized list, properly arranged, then you can go into your BOQ and then look at it, and then you're able to know how much it has cost you up to that level. Okay, so I was saying valuation of works done, and then so at any point, the works that have been done so far can be measured off the bill of quantities, because even payments and all are made based on the bill of quantities. And then it provides a basis for the valuation of variations, which often occur during the progress of the bill of quantities has already been kind of works. So as these works are being carried out, you find there are other works that will come in. So when we look at this, we shall be able to, using the BOQ, we shall be able to value for these valuations, still basing on the already existing BOQs. So that's how important priced. It provides a basis for cost. Simply saying if money you're supposed to spend on your building, then you can actually make plans of how you going to construct your building in the different phases and so on and so forth. So those are the purposes of the BOQ. And then so as we carry on, always feel free to jump in wherever there are questions, because that way it will make it easier other than proceeding and moving forward. And leaving some people behind. it has two main processes. Okay, taking off. So we're saying this is a process in which dimensions are scaled already from the drawing and entered in a recognized form on special ruled paper called the dimension paper. So this is going to be much of our point of focus, especially as far as measurement of works is concerned. This is the main focus. Taking off. So we shall really dig deeper into it and we shall be able to see it. Then we have the second part, which is working up, which involves squaring the dimensions. Still this, we shall see. Transferring the resultant length, areas, and volumes to the abstract where they are arranged in a convenient order for building and reduced to the recognized units of measurements. And then we have the building operation where the various items of work making up the complete job are listed in full with the quantities involved in a suitable order under section heading, of course, with their costings. So these are the two sections for preparing a BOQ, but our focus is going to mainly be on taking off. Okay. Okay, so now we want to move forward and look at, I'm having some issues with my computer as it freezes a bit sometimes, so have to just give it some time. Okay, so in our measurement of building works, we use the standard of measurement is we use the standard method of measurement of building works, SMM, issued by the Architectural Association of Kenya, that. So what does this imply? Even as we look at other things, say, normally in civil engineering, we have what we refer to as codes. We deal with codes and so on and so forth. So for quantity surveying, we use what we refer to as the SMM. And the other document that we use is the document we refer to as CSMM, the civil engineering standard method of measurement. So Okay, so this is our main focus. Okay, this is our main focus, the SMM. However, there is also different areas have different so as for us, we shall be following the SMM. Okay. Okay. So we carry on. Who does this work that we are going to be looking at? So I'll be skipping some of these things because I believe you can easily read through and you'll be able to follow. So we move to the quantity surveyor. The functions of the quantity surveyor. How do you come to a quantity surveyor? Who does this work? Basically, a quantity surveyor does this work. However, in today's world, even the civil engineer is expected to be able to. The civil engineer is expected to be able to do this work. How so? For example, take a look at this class. This is a class for civil engineering students, but we are covering quantity surveying. And you find that today we don't have so many people coming out as specifically quantity surveyors. So anyone should be able to do this work. Okay, so what is his purpose or what's his job? The first one, the main purpose is of course preparing a bill of quantities. But apart from that, apart from preparing the bill of quantities, what other works is he supposed to do? The first one is preparation of appropriate estimates of cost in the very early stages of the preparation of a building project. We normally have what we refer to as pre-tender estimates. Before we come into having a final BOQ for the construction and all that, they are what we call pre-tender estimates that are used for planning and so on and so forth, what we're referring to as early stages. So the quantity surveyor or the QS is responsible for preparing these estimates. Then we have cost planning during the design stage of a project to ensure that the building obtains the best possible value for his money. And then we have examination of tenders and prices of quantities and making recommendations for a way forward contract. Okay. So then we have preparation of schedules of prices and negotiation of contracts with a single contractor, among so many surveyors. Now, for our focus, we say we follow the SMM, and here we have the general principles of taking. We have the general principles of taking off. We have the general principles of taking off. Here we have rules. I'm not going to move through these rules now. And makes followed in of one bill of quantities shall fully describe and accurately represent the works to be executed. So here it's ideally saying your BOQ should have a proper description. Somebody who handles a BOQ or who reads your BOQ, they should know exactly what work they are going. If the work to be done is cutting down a tree, your BOQ should clearly state Is the tree going to be cut down at 1 meter above ground and that's it? Or is the tree going to be cut down and also the roots uprooted and so on and so forth? So your description should clearly describe this. Okay. Then we carry on. So I'll just skip those clauses. We shall come across the in time. Now we read or scale of dimensions from into a recognized form of paper, which we refer to as the dimension. So we now need to move to the dimension here, a simple plan that I can just share with us and then explain something small. I don't know if we can see the plan. Can we see the plan?
Yes.
Okay. Now, so how we deal with this is I just want to explain the other part of this part here. Just before we carry on here, we is that whole process in which the dimensions are scaled or read from the drawing, right? Because that's basically all we are going to be doing throughout this semester. When we come to the plan, you're going to find we have the dimensions here. For example, this is 12,300, we have 1,800 here, and so on and so forth. We have those various dimensions. Yeah, you can see those. Now, what you see in the dimensions here on the plan are what we refer to as figured dimensions. Yeah, like you can come and know this window is 1,000 straight away. However, there are times when you cannot tell a given dimension. For example, from here to here, there is no what? There is no dimension, right? But for this case, it is simple. It's just a matter of getting this minus this, then you divide by 2. That case is simple. You can get the dimension. But imagine a situation where you could not get this dimension, right? For example, you didn't have this dimension also. You need this dimension of the wall, but you don't have it. In that case, we bring in our ruler and we measure. Then using the scale of the plan, we're able to, I believe you remember those things in geography. Yeah, using the scale of the plan, we're able to determine the dimension. So that's what we call scaling off. If we come across it as we take off our plan, we shall be able to fit. But mostly we're encouraged to read figure dimensions because they are more accurate other than scaling off. Okay, now we need to remember, we need to note that for you to be able to do this, you need to be able to know how to read a plan, right? You need to be able to look at this plan, understand it, analyze it well, and you will be able to take off. Without being able to understand your plan, you cannot be able to take off. Yeah, we have the plan. Then we can also have a section. The things we use, we use drawings. You should be able to understand all these drawings. We also have, we can also have a section. So this is a section which you can, this is a section, as you can see here. So from the section, you need to be able to read off certain things, because you can see it's a section that gives you the footing and the height and so on and so forth. So you need to be able to read your drawings and be able to interpret them well. Okay. Let's get back to our dimension paper. Okay. Now, for our dimension paper, we're saying we have our sheet of paper. We do this, maybe if you had a sheet around, it would help. So that's because now what I would encourage, I don't know if we have notebooks as we come for this class, because now the part that we are going to, I would prefer it's not one where you just look on, but it's one where you actually write. Yeah. As I do this, you also write and try to see that you've understood. I don't know, is that okay? Do we have notebooks, or we just on computers looking on?
So we have notebooks.
Now, here we're saying we have our sheet is divided into two. First of foremost, let me just do this here. Imagine this is my sheet of paper. What I have first is I'll use this line to say this is the division. So what I do first is divide my sheet into two. This is a normal line. I divide my I do double lines. I have 4 lines. I have 4 lines. Say this is 1. I mean 4 columns. 1, 2, 2. Then I have, so that's my second column. Then I have my last. Okay, so those are my columns, 1, 2, 3, 4. And then I will do from 1, column 3. And then, okay. So first and foremost, that's how you prepare your sheet of paper. Now, we number them 2, 3, and then this is 4. It's the same thing this side. Now, now somebody is asking if the lines are equally spaced. In that case, I'll revert to the document so that we can see clearly. The other side I was just showing us so that we draw together. So this is my document. As you can see, 1, 2, 3, basically the same space. The fourth one is big because this is where the description is going to be. So you'll find that this space needs to be a bit bigger as compared to the rest, because that's where the description is. Now, after we've drawn our lines, on this other side, it's the same thing. So what we have is this. This section here, we have 2 modes of operation. The standard mode of operation is this, that this section here is section side referred to as waist. Yeah. This whole section here we refer to as the west side. However, we don't normally do that. And in doing so, we number our page. If we do this, then we are going to number our page as page 1, right? So that whole page is going to be page 1. However, we don't really use that practice, because if we use that practice, we are going to be wasting a lot of paper. So what we do is this. We don't already noted this. So I want to clear it. We remove that, remove that. So what I do is I call this page 1 and I call this page 2, right? So my sheet of paper is divided into page 1 and page 2. So this here is 1 page, and this here is another page, right? So in that case, I'm able to save space. I'm able to save space. Okay, so how do I now operate? So now we come to the operation. So we keep this standard of page 1, page 2. The others, we shall see now where to put the waist. If I've used this side as a given page, so where will I put the waist? We shall see that when we come to waist. Okay, so then we're saying each sheet is split into 2 identical ruled parts, each consisting of 4 columns. The purpose of each column will now be indicated. So column 1 will column in which multiplying figures are entered, when more than one of the particular item is being measured. Okay, so we shall see that. Then column 2 is called a dimension column, in which the actual dimensions as scaled or read from the drawing are entered. There may be 1, 2, or 3 lines of dimensions. We shall see that. That's the dimension column, where we enter the dimensions, in which the length, area, or volume obtained from multiplying together figures in column 1 and 2 is recorded, ready for transfer to the abstract. And then column 4 is the description. Column. Okay, so now how do we enter our dimensions? Entering of dimensions. The first thing is you need to be able to space your work. So I'm going to just run through this and explain it as we're looking through. So we come back to our whiteboard. Entering our dimensions. The first thing has been you need to space your work. The reason for space. The reason for spacing your work is to have orderly working. For example, I don't know if there is anything here, but okay, here we put 1, but for example, after I've written something like this, if I'm going to write the second thing, I need to leave a space, you know, so that my work is not all just added up. That is what I call refer to as waste. Here we're saying use the right-hand side of the description column for preliminary calculations of works. I'll come here and I'll share my plan with you. Let's imagine let's imagine I want this length from here up to here. Are you with me? I want this length from this part to this part, right? So what I'm going to do is I'm going to get these figures. So what I'm referring to as waste is here. I get these figures. The first figure I have is what? There is, I'll use this upper section here, these figures here, to add them up because they are clearer. So I have a 150, then I have a 3550, then I have a 150, then I have a 1650, then I have a 150. So this is what I'm calling my waste work. In simple terms, waste work is referring to rough work. Are we following? So at this point, waste work is basically referring to rough work. So that's basically how we deal with it. Now, we've said we enter it into the description column. So I'll just take that same example and come and operate with it here. So we've said here, we come here, 3550, then I had, what was it? 1650, then I have 150. Okay, yeah. The drawing, yeah, somebody is saying it's 650, not 1650. Yeah, actually, that's an error. The 0 is sitting on the 1, but it is 1650. Then I put the total. For example, yeah, the total is going to be what? I'll just add up this. Don't worry about the accuracy of the figures. I just want to, we just need this for an explanation. 3550, 1650, then 150. That's 5500. So I come here and I draw a line like that. Then I put my answer, which is 5500. Okay, so that is what we're referring to as waste. That's how I operate with my waste. Then after that, that was length. For example, if I'm going to put concrete or brick walls, somebody is saying, I'm not seeing what you're talking about, as in my picture. I don't get that. I don't get what you're not seeing. Okay. Maybe Tony, you can clarify on what you're not seeing, because I'm not really getting it. Because I've shared my clipboard that I'm working on. Okay, so here, this is my waste work. That's how we treat waste. So let me just assume we are going to put bricks, 230 millimeter, clay, bricks, whatever, and so on and so forth. So this is just an example. Our focus was how to deal with waste. This is how we deal with waste. And I've said, where did I get that waste? Waste is rough work. Waste is rough work. I needed this total length here. And it's a combination of It's a combination of these different lengths. It's a combination of these different lengths. So that's why you saw that I have 150 plus 3550. I forgot this 150, then plus 1650, then plus 150. So for me to get this total length from here to here, I had to add up these values. So in order to add up these values, I don't do it from the side. I do it from my dimension paper. That's what we refer to as waste work. Your waste work needs to be shown and your waste work needs to be clear. So that somebody who is going over your work can be able to understand. For example, if somebody was going over your work, like we've realized what I have here is 150, 350, 1650. We have realized that I forgot. What we have is 150, 35, 50, then we have another 150. I didn't add this 150, 1650, then 150. So as somebody is checking through your work, they realize that mistake. So they come here and they make that correction, right? So you need to be able to, it was around here. This was 150. So if I add a 150, it becomes 50, 5650. Okay, 5650. Then here, just try and do this line. Yeah. So I believe you can see the point. Huh? So if your work is arranged properly, somebody who comes to make a correction in your work can easily do that. Can easily do that correction. Okay, so that's it for waste work. Now we carry on entering of the. We're now looking at, we've looked at waste. So now we look at the order of dimensions. If you can follow in your notes, you will find that we have that our order of dimensions. You find that our order of dimensions is length, then we enter the width or breadth, then we enter the depth or height, in that order. Yeah, we enter it in that order: length, width, breadth. We enter length, width, breadth, and then the depth / height. Okay. Now, so how do we enter? What are the units of entering here? When we're entering in the dimension, now this is entering into the dimension column. Leave alone this waste work. The waste work is okay, you can write it like this. But when we're entering in the dimension column, which is our second column, we enter in meters, two decimal places, e.g., say 2.00, right? 2.00. For example, if I was to enter this 5650, I would enter 5.65. That's what I would enter in my dimension column. So let me just do that. We've calculated our length as 5.65. So this becomes 5.65. Yeah. After doing my calculation here and getting 5650, here I enter 5.65. That is my length now. That is my length. So now what I'm looking for is the width or the depth. So in this case, I'll first remove this description so that it doesn't bring any. So here I would enter 5.65. Now, if I had the width, I would enter my width as my width would be, say, if my width is say 0.23. Yeah, let's assume that's my width. Okay, let's say 0.69. That's my width. Now I enter my depth. So my depth is 0.23. Okay, of course these are entered in a straight line, just that I'm working here, so I have something that's a bit funny, but yeah, something like that. After entering my dimensions, I come, I underline like that. Okay, is that clear? So that's how I deal with my entering of dimensions. Now, what are the units of measurements that we have? When entering dimensions, remember we said we carry our resultant lengths, areas, and volumes. So how do I enter them? So we have what we refer to as an item. Then we have what we refer to as a number. Then we have what we refer to as linear meters. Then we have square meters. Then we have cubic meters. So these are the basic five that we. These are the basic five. Yes, Masiko. Masiko, you have your hand raised up.
It was by mistake, sir.
Okay. Okay, so we have an item. How do I deal with an item here? Now, these are I deal with an item. I come in my dimension column, I write an item as or square meters or whatever. So we call that an item. Take, for example, clearance of site, removing shrubs, removing small trees, grass and everything. Like there are a lot of things involved, so sometimes we just refer to it as an item of work. Or some other thing we refer to as an item of work is, for example, we have clearance of termite nests, killing the queen, spraying chemicals and stuff like that. So all those works refer to it as an item. So in my dimension column, I'll put item, and then I'll put the description. When we come to number, say you're cutting down trees, and I have a given type of trees, I'll put one type of tree. That's how we deal with the number. Okay. That's how we deal with the number. Now, okay, that's how. But now, after that, we come the number. You see that. Remember, we said the things we enter in dimensions, in meters, we put to 2 decimal places. Now, for a number, it's to 1 decimal place. So this is a number, right? This is an item. This is a number. Now, linear meters. What will tell you that it is linear meters? You will find, for example, 2.00, and then you find a line underlined. This should tell you that the unit of measurement here is linear meters because it only has one level. And if you were to proceed to square meters, you'll find we have, say, 2.00, and then maybe 0.50. And then you have your line. When you find two of such, then you know the unit of measurement is square meters. When you find it is three like this, 1, 2, 3 levels, then you know that is cubic meters. 3 levels, it's cubic meters. 2 levels, it's square meters. 1 level, it's linear meters. No decimal places, it is number, and then here it's an item. Are we together? Okay, I just hope no one is being left behind. And in the case one is being left behind, please you alert us. Okay, so that is what we refer to as order of dimensions, right? Okay, now I'll go back to our document. Yes, Gilbert. Gilbert, your hand is raised. Somebody is saying pardon on the last statement. Okay, now I don't know which last statement. I have people raising their hands, but they're not speaking. Tony, your hand is raised.
Okay, thank you, sir. I wanted you to help Mandy pardon for me on the recordings of where we have 3 figures, the 2 figures and 1 figure. I have
Okay.
not understood it. Thank you.
Okay, Gilbert, what were you saying?
I was saying that you would pardon me the same as Tony is requesting.
Great. Okay, I have said we have 5 units, 5 major units of measurement. We have the item, we have the number, we have linear meters, we have square meters, and then we have cubic meters. Is that clear? So now, item, just write item. If it is number, if it's a number, for example, number of trees to be cut down, we just write the figure. We just write the figure. Right? And then we have linear meters. We have linear meters. For linear meters, we say anything in meters, write 2 decimal places, right? Like this. But if you find you have only one figure, like 1 level, that is linear meters. If you find you have 2 levels, in this case, it is 1 level, it's just length, right? When it's 2 levels, it's length and width. But if it is 2, length and width, or length and depth, then it is square meters because it is length times width. Then if it is 3, length, width, depth, that is cubic meters because it is length times width times depth. If I could just add something here in brackets, this would be length times width times for volume. Then square meters. Then for linear meters, it is just length. I hope that helps. Okay, so to carry on, we have into that. What we have looked at is the dimension column so far, and now we enter the dimensions into the dimensions column. Order of dimensions, I've discussed the order of dimensions. Now the time using column. If there were 3 such items, then the dimension would be this. For example, we are preparing plain concrete grade 15 in beds, but there are 3 places. So we put the dimensions and then we put the 3 here with the slash. Yeah, we put the 3 with a slash. For example, if I'm to go back here to my board, if, for example, here, this one is indicative of the type of trees. But let's assume that given type of trees, there were 7 trees. I would write 7, then I put that slash in the time using column to indicate that there are 7 trees of this single type. If these 2 were, I was laying pipes and there were 3 pipes, then I would write 3 pipes. You get that? So that's how we deal with the time using column. It is indicative of the number. It's indicative of the number of items. Now, let's assume I have my 7 here. I mean my 7. But then, as I was dealing with the 7, I found out that there was another tree that I had not considered. In this case, we do what we call the other 2 trees. We do what we call dotting on, 2 dots. Yeah, which is 2.7. So in this case, the dot means the dot simply means plus. I have dotting on implies addition. Okay. Excuse me, just a minute. Okay. So I was saying about that. Dotting on implies addition. Yeah. Dotting on implies addition. That is here where I've tried to do an example of dotting on. It is 7 plus 2, right? So originally I'd put 7 trees, but I discovered there were 2 additional trees. So I got 2 plus 7. That is dotting on. That's all done in the time using column, which I'll see more and so on. So that is what has been explained here. So you can see here, it was, so for example, here there is a 3, and then if it was subsequently found that a 4th bed of concrete of the same dimensions was to be provided, then a further one could be added in the time using column, the process known as dotting on. That is 1.3, implying 4. Okay. Now, abbreviations. In our description, we use abbreviation, because if you don't use abbreviations, you'll find that the words you have to write will be too many. So we tend to use abbreviations. And the list of abbreviations is attached. You can always find it and read through some of the abbreviations. Okay, that said, then we have what we refer to as grouping of dimensions. I'll just come here and give an example. I'll just go to the clipboard. Okay, let's assume, I'll use this part here. Let's assume I have a description. This, we have 2 options. I have one single dimension, but this dimension is the same for different types of works. For example, excavate trenches. Now, I'm not writing full descriptions. I'm just writing something simple so that we can work with it. And and then here I'll write return. Okay, now okay, so we're here. So now you realize this is one dimension, but it is serving excavation of trenches and return, fill, and ram. So if I have two descriptions or three descriptions, but for the same dimension, then I just use this and sign. I just use the and sign, first description and second description and third description, like that. Now, what if I had a scenario whereby same description but different dimensions? So I have 7.25. Then I have say what, 0.56 and then 0.23. Same description but different dimensions, right? So here we do what we call bracketing. Ideally, you would have drawn your bracket like this. You draw a bracket like that. So I'll just do this. So that is my bracket to show that both these descriptions are to that. I mean, both these dimensions are to that description. That's how we group dimensions. You can either group dimensions. You can either group dimensions based on this, where you have same dimensions, one description, or you can have a dimension and different descriptions. Okay, so that is grouping of dimensions. Then we have what we refer to as deductions. Sometimes we may need to deduct. How does deducting come in? I'll take us to the plan and show us an example. When I come to my plan, I don't know if you can realize, but when I'm here, my plan is basically coming like this. I don't know what should I use here. My plan is here, right? But if you look up here, my plan stops here and here. So it's like I have this whole area here. I have that whole area. I have that whole area. As you can see, this area, it's a void. It's not part of the plan. But when I come to read my plan, I'll just take this 12,300, which 12,300 starts from here up to this side. And then when I come on this side, I'll just take this 12,700, which also starts from here to this side. So it is important that as I take that, I need to be able to deduct this section, right? We call this a void. When we start taking off, we shall be able to look at it. So what I do is, for example, you can see here, they took the total length of the plan and total width of the plan. Then they deducted those small sections that I've shown you. Those small sections, for example, in this plan, we would have that section, then we would have this section, right? Those are two sections. So they come here, they deduct them. The first one is 7.6 by 4.6, the other one is 5 by 5. And we use deduct, which we underline ditto. Ditto simply means as described above. Instead of repeating this same description here, deduct this. We just use the word deduct ditto, right? And now this is a typical case of where you have to bracket. You have to bracket this. You have to bracket that because these are two dimensions and they all belong to this description. Okay, can proceed. Okay, we need to underline the word deduct. Okay, now we have what we refer to as measurement of irregular figures. Now, irregular figures, we're talking about figures that have a constant in their formula for area or volume. For example, area of a triangle is half base height. This half here is not a dimension, so we cannot put it in the dimension column. So we put it in the description, I mean in the time using column because it's a multiplying factor. So we put it in the time using column as half and then we put that. If it was a circle where we have pi, for a circle we have pi. Where am I going to get that? Anyway, I'll just use 22/7. For the circle is 22/7 r squared. Now, the r is the dimension. So when I come here, I can put, say, if my r is 2, I can put 2.00, 2.00. But I cannot put the 22/7. So what I do is, I come in the time using column, and then I put the 22/7. And remember, I have to put that slash at the end. Let me use 3.14 so that it looks a bit. Yeah. So this is not 3.14, it's 3.1 for the pi value. Then I put the slash. Or you can just write 22/7. Then I put the slash. Remember, I need to put the slash. For the slash, let me use this. Let me use this slash. Yeah. Okay. Now, that's basically how we deal with that figured dimensions. Okay. Now, I have alteration of dimensions. In case you make a mistake, you don't rub and do what and what. You just come write the word nil, and then you write the correct stuff. Yes, Joram.
Yes, sir. I have not understood where that ranges in my network was disturbing me. I beg your pardon there.
Where the what?
That ranges where you calculated that ranges in the other sheet.
No, I didn't calculate ranges. I was just giving an example. I didn't calculate. I was just showing you an example
And you have,
of if I have one dimension.
and I've not.
This is about grouping of dimensions, how to use a bracket and how to use the and. If you have a dimension, but you have more than one description, you write the first description, then you write the and, then you write the second description, right? So this is for multiple descriptions. We use the term and. If you have multiple dimensions, but for the same description, we use this bracket, like you've seen. We use the bracket to show that this dimension and this dimension all belong to this description. Is it okay? And then also,
Okay,
look,
thank
the description and my dimensions are in the same line, you know. It's not that the dimension is here and then the description is up or down. No, they are in the same line. Okay. So we use the term nil
okay.
to, you know, to show that this is wrong and so on. So now, basically, those are some of the major things that we look at. The rest we shall get to look at as we move forward. So my request is going to be that you read through these definitions, because some of these definitions are just to be read, schedules, query sheets, you know. Just read through this, and then when we come next time, we shall be able to move on to chapter 2 and start taking off. We shall move on. I will send us a plan which you will be able to print out, and we shall work using the plan, because we need to work using a plan. We take off from a plan. Okay. So unless somebody has a question, I want to end the class here, at least for the introduction. So that we don't have a lot, we can go practice this, go through the chapter 1. Go through chapter 1 as you practice with this, and make sure that you are taught with everything and that you've understood everything before we move forward. Because if we move forward and you've not understood the first part, we are going to have problems. Okay. Okay, so have a good day. Wish you well. Jonathan, your hand is up. Yes.
Yes, sir. And the other sheet, you said you have a west sheet, a first page, and then the west sheet. And I saw you saying we should name page 1 and page 2, and we leave out the west sheet. Well, now
Yes,
how
exactly.
can you work out the west sheet?
The west is here. I showed you how to work with the west on the right-hand side of the description. So instead of wasting this whole side, we just do the west here. Like for example, this, if I'm coming here, I do the west, I get the dimension I want, then I do the work here. I put the 5.65. So instead of wasting, just doing this simple work, I waste this whole space. No, I save my space. I consider this page 1. That's my page 1. Then this is my page 2. My west, I do my west in the description column at the right-hand side. Okay.
Oh, thank you, sir.
Yes. So I wish you well, and yeah, all the best.
Thank you, sir.